Yes, guys. So basically, we're talking about grouping of data, right? Yeah. So as I was saying, whenever you're creating these categories, right? Remember, we're doing this because we can't go. Let's think about this realistically. If I had to draw a table here now, right, and I've had all these decimal values, and if in each line I go say, this must be 150.1, this must be 150.2, this must be 150.3. Can you see how impractical that would be? So instead of doing that, we just say, okay, create a category that would encompass all of these values. So between 150 to 160, 150,1, 150,2, and 150,3 would all fall under this category. And so under the frequency side, we'll say, okay, three values fall within this category. Can you see that? So that's basically what we are doing, because we're trying to simplify this data set, and you're going to use this extensively. But what's important to remember is that the intervals that you define must be non-overlapping. So you can't put 160 there and have 160 here as well, because then your frequency values are going to go off. Right? So if you end at 160, you need to start at 161 here. Okay. So yes, that's very important. That spans the full range of the data set. And you need to make sure that when you put the intervals in here, they must be able to take on all the values. So you must be able to put all of the values from the data set that you get into a specific category. If some values are left out, then you're going to have a problem, right? You're going to have a problem. Once these intervals are set, we count how many data points fall within each one, and this transforms a continuous data set into a more structured form, making patterns easier to interpret. And importantly, this method isn't limited to continuous data. When dealing with a large volume of discrete data, such as responses of dozens or hundreds of unique values, grouping is still essential. For example, if 150 people each gave a distinct response or score, trying to display each single one as a single binary histogram would be impractical. And so if I had the entire grade 10, the entire grade 10 students marks, and there were 150 of them, and if everyone scored a different mark, let's say there were 100 of them, right? Let's say there were 100 of them, 100 students in grade 10, whatever school this is, right? And student 1 scored 1%, student 2 scored 2%, next one scored 3. And that pattern continued. And the 100 students scored 100%. How would you do this? Are you going to go on the table now and you're going to write 1, 2, 3, 4, 5, create each line, and then under your frequency side, you're going to say 1, 1, 1, 1, 1. What useful information are you going to get from this? You can't, right? It's very impractical. So what we do is we say, okay, from 1. So what we do is we say from 1 to 10, something. From 11 to 20, something. From 21 to 30, something. Okay? So that's what we need to remember. You can't go and have 100 distinct or 100 different lines in your paper. So this is why we say, just if you're dealing with a very large data set, one, or if you're dealing with continuous quantitative data, then you have to categorize them. Very simple stuff. Okay, then one of the most effective ways to visualize this grouped data is histograms. So now we finished learn how to organize the data. Listen to this. We finished learn how to organize it. How do we organize it? Using grouping of the data. Now we're going to talk about visualizing it. How do we do that? Using a histogram. On the x-axis represents the intervals. So you see these intervals that we created now, like 150 to 160, 161 to 170. We put them here. Interval 1, interval 2, interval 3. Okay, guys? And then on your y-axis, we'll have what we call the frequency. So on the frequency side, how many people belong to this category? How many people belong to this category? How many people belong to this category? And we just do that continuously. Okay, so here you'll have intervals, and on your y-axis you'll have frequency. Now remember, this is very different from a bar graph. A histogram, the bars must be adjacent. They must lie next to each other. And the reason we do that is because it shows that the data is flowing. Right? There's a flow in the data because it's continuous and not discrete. Right? Remember that, please. That's a very important, minute detail. Right? Histograms, there's no spacing. Bar graphs, there is. Okay? And then, yeah, the graph should contain a descriptive title below the graph. axes should be labeled with a name of the variable, units, and intervals. So here, if the intervals were heights, so we'll say intervals of heights, and in brackets you'll put meters. You have to put the units of measurements. If you're doing physics, Lumia does physics, I think. This is very important. Right? Being very specific with your titles and what is going to be extremely important. So you need to do that. Okay? And a key to indicate which data points belong to which. So let's say that this was tracking both males and females. And then we had the black ones are for females and the purple one is for males. Then for each interval, you'll have a black bar representing the heights or the number of females that belong to this interval, and the purple one will represent the number of heights of males that belong to that interval. So you need to draw a key here, but we won't be given this. Right? But I'm just showing you. If you're representing two data sets on a single histogram, you must include a key. The purple bars represent females and the black bars represent females and the purple bars represent males. Right, so one more time, this is an histogram. At the bottom here, you include a descriptive title. Yes, and then yes, each of these bars would represent something, right? So it will represent either heights or whatever. And then on the y-axis, we have the frequency. Any questions so far?
No.
Dan?
No.
Okay, right. We don't worry, we're gonna do an example on this. I'm just showing you the theoretical aspect. So right, let's do an example. Here's a sample data set of 30 people's heights in centimeters. Okay? Now think about this. Are you going to go write 30 different lines for each of these heights and say that one person belongs to each height? No, that's impractical. So what we're going to do is we're going to group them because we're dealing with a large data set. Therefore, we will use grouped data intervals or we use ranges. Okay? So if we do that, we can do it in one of two ways. We can do this one here, listen to this, where we put them in intervals. This is what we call grouped class labels here. Or we could use the idea that we talked about under sets, which is what? Set builder notation, right? So we can say, look at this here, two ways of saying the exact same thing, right? What would it be? Listen to this. This one says that in this category, it must start from 150 and end at what? 159. In this category, it must start from 160 and end at 169. Here, this is saying something else now. This is saying the exact same thing, right? Just a different way. You're starting at 150 and you're ending at what? 159. Can you all see that, guys? We're excluding 160. So it's two ways of saying the exact same thing. You can use whichever notation you wish. Can you all see that? And you can see that's basically what we're doing, right? So this is just two different ways of saying the exact same thing. But what I stuck with is what? The set builder. So between height ranges, so the people's height from 150 to 159, how many heights belong to this category? Two. So if I want to do a tally table, I'll do 1, 2, and that will be that. Between 160 and 169, the number of people that belong to this class will be what? See, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right? And then we put that here. But now, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so it's supposed to be 10. But anyways, you can see that how we got that here. We get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right? After every fifth stroke goes diagonally. Again, you do the exact same thing for all of the other intervals. When you do that for all of it, if you add it up, it should give you the total number that you started off with. Should give you 30. Can you see that, guys? Because it has to cover the entire data set. All of these intervals have to cover the entire data set. Right, that's one way of organizing it. What's the second way? Let's use a stem and leaf plot. Now, this was tested in a Caltech paper. So you'll have to know this, right? I'm certain that your teachers are going to overlook this, but you'll have to know this. You're writing internal papers now. That's why you won't get tested on all these minor things. But when you write department papers, these things are still examinable. So you'll need to learn it. Okay? But it's very simple. We're doing the exact same thing, but with the stem and leaf plot, this is what we do. The stem represents so see what we're dealing with. We're dealing with 3-digit numbers here, 158, 164, right? We're dealing with 3-digit numbers. When we're talking about the stem takes every digit but the last digit. So we're not taking the units, we're taking the hundreds and the tens, right? And we put it in here. And so if you look at this, if you go back here, you can see that we got 15, 16 here, we got 17 here, we got 18, and then we got 19. Can you all see that? And then what we do is, in the leaf column, right, in the leaf column, we take the units and we put it in here, but we must put it in ascending order, right? So we take the units and we put it in here. So under the 150 category, we have 152 and 158. That's where we put 2 and 8. Under the 160 category, we got 0, 1, 2, 4, 5, 5, 6, 7, 8, 9. So that's what we'll put here. 0, 1, 2, 3, 4, 4, 5, 6, 7, 9. You'll see that. So in the stem column, we're putting every digit but the last number. In the leaf column, we're just putting the last digits, but we must put it in ascending order, right? So from smallest to biggest. And most importantly, at the bottom here, you must put a key. And what that key would represent is, see, 150 bar 2 is the same as 152. And so if you have to take this here now, see if I was given this and I needed to draw information. The first line is telling me 152 and 158 is a part of the data set. The second line is telling me that 160, 161, see, first two and that digit. Then 162, then 163, then 164. 164 is twice. Can you see that? Is a part of the data set. So that's what it is basically telling me. Okay. From this, I can read so many things. What can I read from this? I can see that 164 and 170 are the modes of this data set. So 164 centimeters and 170 centimeters appeared the most frequent in this data set. Can you see that? So you can read a lot of things from this. Okay, I can find the median, whatever, right? But we'll get to that when we get to that. Okay, so that's the stem and leaf plot. Very simple stuff there. Okay, so now we know frequency tables. See, frequency tables is basically this here. But then once I put a tally column in it, then it becomes a tally table. And then this is stem and leaf. So now you'll know how to do or organize data in these two techniques. And then lastly, to represent it, how do we do that? See, to draw a histogram, you must basically draw bars that lie next to each other. Okay, then you'll draw a frequency on the y-axis, and then you'll do it in increments. So you'll do 1, 2, 3, 4. Remember, this has to be to scale, okay? So this has to be 1. If that's 1 centimeter, then you go in 1 centimeter increments. Then in the bottom here, if each bar represents 2 centimeters, it must be 2 centimeters throughout. Okay? Then I take all of these categories here. See these categories here that we created? And we write them here. And then we ask ourselves, how many people or how many participants belong to this category? It's 2. It's 2. So therefore I'll shade 2. So I come to 2 and I'll draw a bar like that there. Then next to the bar, we do the next interval. How many belong to there? 9. Can you see that? And then you do all of that together. And yeah, they must lie next to each other. And that's basically a histogram. Okay, can you see how I did it here? On my x-axis, I said these are height, but what I included my units of measurement in centimeters. And here, this will be frequency. And then the bottom, I put a nice descriptive title, which will be a height ranges of participants and frequencies. So how many people belong to this category? It's 2. How many people belong to this category? It's 9. How many people belong to this category? 12. Okay? Because now what they can do is they can give you this here, and they can ask you to find the median, find the mode. They'll ask you, what's the modal class? What's the modal class? What's the interval that appears the most? It's this one here, 12, right? Because 12 people belong to this interval. So that means there's, instead of saying mode, now they say modal. See, they use the word modal class, because now we're not talking about distinct values. Now we're just saying ranges. We're talking about ranges. Okay? So yes. that's that. And then lastly, frequency polygons, they tested this as well in one of the papers. How do you do it? Very, very simple, right? You follow everything that we did for the histogram. But now what we're going to do is, we're going to do the following. We're going to create an interval that comes before the first interval of your data set. And you're going to create an interval that comes after the last interval of your data set. So before this will be what? 140 and 149. Think about it. If we went in like this here, 150 to 159, what will come before it? 140 to 149. Okay? And then the last one here, the last interval is what? 190 to 199. So this will be 200 to 209. Can you see that? Right? Why do we do that? I'll explain exactly why we do that. And then this is the key thing that you'll need to remember. A frequency polygon is the same as joining the midpoints of the histogram. Let me say that again. A frequency polygon is the same as joining the midpoints of the histogram. So remember, each bar here represented something for each interval for the histogram. You find the midpoint of each bar, put dots on them, and then these intervals here, remember I told you create one before and after. So what do you need to do? Put the dots there, and then you join all of them together. Right? You join all these points together, and this is what we call a frequency polygon. Now, the reason we create intervals before and after, see, before and after, why did we do that? Because what's a polygon? What is a polygon? It's a many-sided, it's a figure that has many sides, right? But it's most importantly an enclosed figure. So if I didn't have these points here, this one here and this one here, the diagram would have started here and it would have been what? Opened. So we need to anchor. That's what we say. We need to anchor the graph. So that's why we write an interval before and after. So in essence, this here is a closed shape. Can you see that? This here is a closed shape. Can you see that? But if I didn't have that, then it wouldn't have been closed. That going back to definitions, it's a polygon. And then yeah, you put your same titles, your descriptive titles, and then you label your axes. Okay, guys, so that's literally very simple. You create your frequency table, your classes, find the midpoints of each class, plot each midpoint against its frequency, and then connect the midpoints and anchor the graph. Okay, so yes, that's that. Right? Remember I said it's the midpoint of the frequency of the histogram. So it's here. Yeah, 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 yeah. And then you join it. But you can't, you need to anchor the graph. I told you that, right? You need to anchor it. Okay, so that's that. We talked about the organization of data. Right, that's how we organize data. Now let's go to the how. Let's go to the how of summarizing and summarizing data. All right, so remember, guys, let's go. I just want to really drive the point home. We're doing 4 things: collecting, organizing, summarizing, and representing. By now, you all should know how to organize and represent data. You'll just have to put it to practice. But the organization and the representation of it is extremely important. You'll know how to do it. Now we're going to go to the summarization of data. And please, because your teacher will not do this here for the next couple of weeks, does not mean that these things are insignificant. You'll have to go and learn these things. Stem and leaf plot was already done in grade 8. So the department has the liberty to test you on this work at grade 12, because they're going to say that this work was supposed to be done at grade 8. This is why I'm bringing it back in. Okay? Please, frequency polygons as well. All work done at grade 8. Whether your teacher left it out or not, that's not the department's problem. So this is why you'll have to go through this work and make sure you all understand it. You'll have to. Okay? Yeah, and then we can literally just skim through this one, yeah? The mean. How do you find the mean? Very simple. The mean is found by adding each data value and dividing it by the number of datum. And so how do we denote it? We say x bar is equal to, add all of the data values, right? And then divide by the number of data. The median, I will show you exactly how to do that. But the most important thing that you need to remember is that we have to arrange the data set in numerical order. So it has to be arranged from smallest to biggest. That's a must. Otherwise, you can't find the median. And then the mode, right? I put an asterisk here because I'm going to explain it, right? And then the mode, how do you find the mode? You basically just read it of the data set. What's the most occurring value? And you would read it. And sometimes you could have many modes. And we could say it's bimodal or whatever. But you could have maybe you could have two 70s and two 65s. Then the mode will be 70 and 65 because both those marks appeared the most frequent. Then under measures of variation or measures of dispersion, we have these three things that we need to talk about. Don't worry about this. Range is basically your biggest value minus your smallest value will give you your range. So remember, to get the median, we needed to arrange the data set from smallest to biggest. So when you're finding all these values, it should be simple because you take your biggest value minus your smallest value and you'll get your range. Outliers, I will explain how we get to that, right? But basically the definition of it, it's a data point which occurs individually and do not behave according to the trend described by the rest of the data. So to say someone that is an outlier means they performed exceptionally, right? They performed, the marks are 100 plus %, which is even impossible, right? Or it's extremely low, but it doesn't behave according to the trend of the data set. Right? But what we want to do here with outliers, we don't want to say, okay, this is an outlier because I feel that it doesn't behave according to the trend. We want to have something more anchored. Give me a calculation that I can use to classify something as an outlier. Right? That's what we are going to discover. And then we have quartiles which divide the data set into 4 parts. So let's get tactical now. Now we're going to learn about quartiles, and then we'll be able to find out outliers and median. For outliers, we divide the data set into 4 equal parts. So here's a data set here. We're going to basically break it up into 4 parts, 1, 2, 3, 4. Okay, and we're gonna use a certain technique. I'm going to show you now. Right. For quartile 2, whenever you're finding quartiles, listen to this. You must first find your quartile 2, right? But our approach when we have an even data set and an odd data set will be slightly different. That's why I broke it down here like this for you. I said when there's an even number of datum or data, we have to apply a slightly different approach as when there's an odd number of data points. When there's an even number of data points, what do we do? What do we do? We find the middle. So let's find the middle here. See, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The middle, there's no actual middle. Think about it. The middle is here because there's 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. And so what we're going to do now is we're going to find the average between these two values. So when you have an even number of data sets, there is no actual middle. So what we do is we add the two values that is closest to the middle and divide by 2. And that will give you an answer. Guys, please, this is very important. If you have an even number of data points, there will be no exact middle point. So you take the 2 that is closest to the middle, add them up, and divide by 2. Okay. Once you have that, to get what we call quartile 1 and quartile 3, it's very straightforward. See, after I found this, you'll basically already have the lower and the upper parts of the data set. So this is what we call the lower half and the upper half. From the lower half, how many points do we have here? We have 5. So this the quartile 1 can just be read from it because it's odd. There's it here, 49. And in the upper half is the same story as well. There's it here, 79. So now we got quartile 1, quartile 2, and quartile 3. Right, again, even number of data sets, there will be no exact middle point. Okay, what do? Is we find the the values closest to the middle, add it and divide by 2. That will be the middle. After you do that, you will already split the data sets into a lower half and the upper portion. And once you have that, then you'll be able to read your quartile 1 and quartile 3. All right, so let's take an example so that I make sense here, right? How many values do we have here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's an even number of data values, so therefore we have to find the 2 values closest to the middle, add and divide by 2. So if I do that, 1, 2, 3, 4, 5, it'll be here 1, 2, 3, 4, 5. So now we have the lower half, upper half, and we add these 2 values, divide by 2, we get 65 or 62.5. The lower portion is what? 5 values. Can you read the middle from it? Yes, you can. There's it here. The upper portion, can you read it off the data set? Yes, you can. There's it here. That will give you a slightly more complicated example. Here, there's 20 values in it, right? Since it's even, there is no exact middle point. So what we need to do is 20 divided by 2 is what? 10. So we need to have 10 in the lower portion and 10 in the upper portion. So let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And this side here should have 10. So the middle is right here. Add these two values. 75 plus 75 divided by 2 is 75. So that's my quartile 2. Now if you look at the lower portion, see what do we have? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Can you find the half of 10 here? You can't. There'll be no defined point because it's same as saying, we have an even data set. So we can't break this down, or we can't pinpoint the exact middle when there's an even data set. So what do? Again, 10 divided by 2 is what? 5. So we need to have 5 here, and the middle will basically be the 65 plus 65 divided by 2, which will give you 65. Okay, guys. So what I'm saying is that when you have an even data set, there's no exact middle point. You always have to add the two values closest to the middle and divide by 2. See, same story here. Here there'll be 10. It's even. Can you split this data set into a precise middle? No, you can't. So you have to add the two values closest to the middle and divide by 2. But when it's odd, it's child's play. Very simple because you can pinpoint the middle. Like look at this one here. Here there's 1, 2, 3, 4, 5, 6, 7, 8, 9. So the middle will basically be this value where there's 4 here and 4 here. Now excluding the median, look at the lower portion and the upper portion. Right? The lower portion, there's 4 values. It is what? Even. Can you pinpoint the middle when you have an even data set? No, you can't. So again, find the two values closest to the middle, which will be 5 and 7. Add them together. 5 plus 7 is 12 divided by 2 is 6. Can you see that, guys? Same story here. There's 4 in the upper portion. Can you find the exact middle? No, you can't. So therefore, you have to add the two values and divide by 2, you get 16. Okay, so that's what you need to remember there. So here's a nice useful formula here. The way we remember this now is what? We say that the median, the position of the median is half the total number of the data set plus 1. The position. And so if I look at the first one, I had 10. It'll be half into 10 plus 1, which is equal to half into 11, which is equal to what? 11 over 2 is 5.5, 5,5. This is a what? A position. Can a position be a fraction value? Can I say you came out 5,5 in the class? No, we can't. So what this is telling you is that the median, the position of the median, is between the what? 5th and 6th value. It lies in between the 5th and the 6th value. That's basically what we are saying here, right? So again, that's formula basically helps you to find the median. Let me say that again here. Okay, let's do it for an odd data set. For the odd data set, it's so simple because I'll say it's half into 9 plus 1, which is equal to half into 10, which is equal to 5. This is telling you that the fifth data point is the median. There's it here. But when let's do it for 20. Half into 20 plus 1 is equal to half into 21, which is equal to 10,5. The position of the median is between the 10th and the 11th. Position values, you know why I use the word n here? Comes from the natural number system. Position values have to be natural numbers. We're going to learn this in number patterns. Very powerful section. Okay? It comes from our natural numbers. I can't say you came out 0th in the class. I can't say you came out 1.5 in the class. Doesn't make sense. It's either you first, second, third, fourth, fifth, and so on. It has to be natural values. And so when you're getting a value like this here, what this is trying to communicate across to you is that what's the two natural values closest to 10,5, 10 and 11. So it's between two values, right? Then you go and say, okay, right, excluding the median, let's look at the lower half. How much do we have here? 10. So to find the Midpoint of 10 is what? There's no exact point again. So we have to take the values closest to the middle, right? And it's literally rinse and repeat from there. But the thing that you need to remember now is that once you split the data set in half, you exclude, then you'll have, once you split it in half, like this here, split it in half, exclude the median, Look at the lower half and look at the upper half, right? When you guys do this, trust me, when you do this, you're gonna make a mistake. I'm certain, right? So this is why you need to use these as rigid rules. When there's an even data set, there's no precise middle. When there's an odd data set, there is a precise middle point. Okay? If you're gonna find the position, it's half the total data set plus 1. But if you're getting like a fraction value, then you take the two natural values closest to that number. Okay, guys. What I'm gonna do is I'm gonna end the session here. We're gonna have to meet up tomorrow because percentiles is a very long section. So we will meet up tomorrow and we'll finish this part up. Okay, is everyone understanding so far?
Yeah.
Then?
I understand.
Okay, perfect. So we're gonna meet up tomorrow. I got the recordings. I'm gonna try to post it on YouTube now or later, and then you can rewatch it. Right, but everything that I discussed here is in the videos. So I'm literally doing the same thing twice. So yeah, guys. Okay, so that's about it.